welcome to Math Archives. In this video, let me explain the concept of half-range sine and cosine series under pi form. Half-range series. So, in many engineering problems, sometimes it is required to expand a given function f of x in a range 0, pi. This is the half of the period, isn't it? 0, 2 pi is a full range or full period. So, sometimes in an engineering problems, we have to expand the function f of x in a range 0, pi. So, if we extend the function f of x by reflecting it in the y-axis, so extension of the function can be done in two ways. One is in reflection in y-axis. The other one is reflection in origin. So, we are going to extend the function by any one of the choice. Either we can extend the function by reflection in y-axis or by reflection in origin. Suppose if we extend the function f of x by reflecting it in the y-axis, so that what we get? F of minus x is nothing but your f of x, which means the extension function is an even function. So if it is an even function, what is the result? We know that is the value of bn becomes 0. Suppose on the other hand, if we extend the function f of x by reflecting it in the origin, so your f of minus x is nothing but minus of f of x, which means the extended function is odd. If it is an odd function, you know already, so the values of both a0 and an becomes 0. So if the reflection is in y-axis, bn becomes 0, which means the Fourier expansion of f of x will consist of only cosine terms alone. If the reflection is in origin, so the Fourier expansion of f of x will consist of only sine terms. So we have only sine series. For example, consider a function. Here I am going to take f of x, a function defined as x and pi minus x. Here function f of x is equal to x in the interval 0 less than x less than pi by 2 and pi minus x in the interval pi by 2 less than x less than pi. Suppose if you draw the graph of the function, if you are going to draw a graph of the function, this is your x-axis, okay? So the origin, if you draw the graph of a function, it seems to be like this. This is a point pi by 2 and this is a point pi and 0, okay? If you draw a graph of the function seems to be like this. Now look at here, the function is defined in an interval 0 to pi. Now I am going to extend the function. Okay, I am just draw one more graph. Okay, the same function graph. Okay, so point pi by 2 here. So this is your x-axis, origin. So point pi by 2, approximately the point pi is here. Okay, now what I am going to do is, so the reflection, as I told you already, extension of a function f of x can be done in two ways. You can extend the function by reflection in y-axis, or you can extend the function by reflecting it on origin. Suppose I am going to extend the function by reflection in y-axis. So what I am going to get, that is, if the reflection is in the y-axis, I get the function like this. Okay, isn't it? The graph seems to be like this. This is a point minus pi by 2. So if the reflection, this is the reflection in y-axis. Okay, if I am going to extend the function, okay, by reflecting it on the y-axis. So I am going to get the function in the whole range minus pi to pi. So this gives me, okay, so this gives me the function in minus pi to pi. Okay, so the other way is you have to extend the same function by reflecting it in the origin. By reflecting it in the origin, so if see the function seems to be reflection of the function in the origin seems to be like this, isn't it? This is a 0.5 by 2 minus pi by 2. Okay, so 0.5 by 2 and pi. So if you extend the same function, okay, so I am going to extend the same function which is the reflection in the origin, you get a graph like this. Okay, so this is the reflection in origin. So the extension of function can be done in two ways. Either you can extend the given function in an interval 0, pi by reflection in the y-axis, or you can extend the function by reflecting it in the origin. Okay, so hence by the property of extending a function defined over interval 0, pi, which is capable of two distinct half-range series. One is sine series, other one is cosine series. Sine series means that is nothing but you have to extend the function. Yeah. What is the meaning of sine series? This consists of series of sine terms alone. Series of sine terms alone. Series of sine terms alone means you can extend the function by reflecting it in the origin. Okay. Cosine series means consists of series of cosine terms alone, which means you have to extend the function f of x by reflecting it in the y-axis. Okay. So sine series means it consists of sine term alone, because in sine series the value of a0 and an becomes 0. So your general Fourier series of the form f of x equal to sigma n varies from 1 to infinity bn sine nx, where bn is calculated by make use of the formula 2 by pi interval 0 to pi f of x sine nx dx. Okay, so look at the formula which is similar to the Fourier series defined for all function in minus pi comma pi, isn't it? This is a formula similar to the Fourier series defined for all function in minus pi comma pi, isn't it? Very good. Next, cosine series is nothing but series of cosine terms alone, consists of only cosine terms alone. So the general Fourier series representation is of the form f of x equal to a0 by 2 plus sigma n varies from 1 to infinity an cos nx, where a0 is equal to 2 by pi integral 0 to pi f of x dx, and an is equal to 2 by pi integral 0 to pi f of x cos nx dx. Look at this. This is similar to the Fourier series defined for even function in minus pi comma pi, isn't it? It is similar to the Fourier series defined for even function, okay, in minus pi comma pi, isn't it? This is also similar to odd function in minus pi comma pi, isn't it? So no need to memorize these formulas separately. These two formulas are same. Okay. So under the concept of odd and even function, we have discussed these cases. So if the given function is odd, we make use of this formula to calculate the Fourier series representation of given function, that is sine series formula, isn't it? So if the given function is of even type, we make use of this cosine series formula to find the Fourier series representation of the given function. Okay, so let me show you the table. So on our half-range series, we are having two concepts. One is in the pi form, another one is L form. Now we have discussed only pi form. Then in my next video, I will explain L form. Okay. So now just look at pi form alone. So cosine series consists of f of x equal to a naught by 2 plus sigma n varies from 1 to infinity a n cos n x, where a naught is equal to 2 by pi integral 0 to pi f of x dx and a n is equal to 2 by pi integral 0 to pi f of x cos n x dx. Here bn becomes 0. Whereas in sine series, f of x equal to sigma n varies from 1 to infinity bn sin n x, a naught and a n become 0. So for calculating bn, 2 by pi integral 0 to pi f of x sin n x dx. Look at here, in pi form, so you have cosine series and sine series, isn't it? Let me show you the formula table for minus pi comma pi. Look at here. So under minus pi comma pi, we have already discussed these cases. So we are having even, odd and neither even nor odd. This even function is nothing but our sine series, cosine series, isn't it? Cosine series. So if it is even means consists of a naught a n, so your f of x is equal to a naught by 2 plus sigma n varies from 1 to infinity a n cos n x, isn't it? So this is your cosine series under even. So odd means that is your sine series. So if it is sine series, your f of x equal to sigma n varies from 1 to infinity, that consists of only bn alone. Bn sin n x, a naught a n becomes 0. So your bn is equal to 2 by pi integral 0 to pi f of x sin n x dx. So hope you got a clear idea about the concept of half range series in detail along with the formula. Thanks for watching. See you all again in my next video.